Hello everyone, this is the presentation for subject INC382 Terminal Automation System project from Group 2. I'm Apiwat and here's the list of my group members. And before we start, I'd like to introduce the outline of this presentation. First, we will talk about overall architecture, then process flow analysis, which is IDF0 in this case, then its process simulation performed in any logic. And we will have a lot of data exported from that, so we will also mention how we manipulate data. Then it's Pi server where we create tag name, design objects in PyAF, and uploaded data to the system. For visualizations as well as report, we have service monitoring on PyVision, OE report in Excel, and software design. So for the first part, this is the overall layout we received from lecturers at the beginning, and each group will have different way to implement, and here is our design. So for the lowest level, all the data will be simulated and exported from any logic. We collect, clean, and group the data together to stay organized, and then upload to PyArchive. The next step is to design different objects with the tag names we just uploaded, and then using PyWeb API to form a bridge between Pi server and our backend. That's number one, connectivity. Then we store the data into our database management tool so that we can easily handle, filter, and sort the data easily by querying it in the code for calculation. And finally, we put the data to our front end for report and visualization dashboards. And also on the left, an icon package, PyDataLink in Excel, will help us generate an OE report, and we can also use PyVision for real-time service monitoring.
In IDF0 is used to produce a function model that is a structured representation of the function, activity, or process within the model system or subject area. By we use Visual to create IDF0 for three perspectives. The first one is task operator perspective. It's the step for the operator in each station that how operator need to do when the driver come to their station. The second one is driver perspective. It will show that when the driver enter each station, what need to be done in each station. The last one is sales officer perspective. It's the working step for sales officer when driver come identify themselves and check for his order.
Hello, I'm Nattakol and my partner Chawia. We are production analytics in Group 2, and we're going to talk about process on task problem in any logic simulation and Excel. Let's see. This is overall of the process. From the start, going to choose gas type between diesel and gasohol. Waiting for going to the sales office, and when driver finish transaction in sales office, they will waiting again to pass the entrance gate and going to wait in the inbound wait station, and then going to wait station in its own type. After that, they going to wait again in the outbound wait station and go out at the exit gate. For overall process in 2D, we can see parking lot has 20 trucks. Sales office has 2, inbound base station has 1, diesel base station has 4, gasohol base station has 2, and outbound base station has 1 truck. In the sort, we can find inter-arrival time from find mean of intermean and represent 2 lambda equal 1 over mean, and we can get lambda around 0.07 and use the exponential of lambda in the inter-arrival time. And this is the exponential graph of inter-arrival time that we get. We can see total of truck is TOT2 and separate to the diesel truck is 2584, that is 83.8%, and gasohol truck is 498, that is 16.2%. So we can choose gas type by use probability in the Boolean. By we input probability of diesel and use Boolean if true that truck is diesel and if false that truck is gasohol. For the sales office, we use triangular mean, max to find the delay time, and queue capacity is 20 trucks, and capacity of officer is 2. Waiting parking lot has capacity 20 trucks. From any logic on task problem 5, we know the travel time of truck between station is evaluated to be 5 minutes, randomly on average. So lambda is 0.2 and use exponential of lambda to find the delay time.
For the entrance gate, I use delay time of 0 because it doesn't have wait time during the entrance gate. The time to wait the truck in the inbound wait station is around 5 to 10 minutes, so using uniform distribution is the most suitable one. In the decel bay, we try to find the suitable distributions by coding, and the result is beta with the value of alpha, beta, minimum, and maximum as you can see on the slide. For gasohol, the result is gen extreme, but since analogic doesn't have command for these distributions, we choose the second place, which is beta distribution with a value as you can see on the slide like this. It's not much different from decel. To calculate the fillet time, we use outlet time minus inlet time and calculate gas volume by multiple fill time with the flow rate, which is 200 liter per minute. We can get waiting time by enter delay time minus arrival time and get service time by exit time minus enter delay time. About the maintenance of base station, the mean time to failure is randomly distributed at 150 hours and the mean time to repair is 2 hours. We have to change the time unit to be minutes by multiple 60. So the initial time to failure is 9,000 minutes. The time to next failure has the same mean time range. That's why we have to use exponential distributions. The last one is time to repair. The mean time to repair is 120 minutes. Find the lambda by 1 over mean and substitute it into the exponential functions. For the failure time, I collect the timestamp of on failure and on repair in fail repair source pool and use these data to find the failure time by on repair time minus what's the failure time on failure time. The wait time of outbound station is the same as inbound station, so we can use the same distributions. The important data that we have to collect is the weight of truck at outbound. To get truck outweight, density of gas multiple to volume before adding the truck in weight. The density of gasohol and diesel is different, so be careful when you calculated it. For the exit gate, we use the same concept as entrance gate. There's no delay time. Let me show you the analogic simulations. This is the process of the task. Let me briefly show you how our 3D looks like. Here, as you can see that the gray and green one is the diesel and the red and purple one is the gasohol trucks. And yeah, it's following in sequence as you can see. Okay, next is let me show you the Excel, the analogic data that converted into Excel. All the data have 3 primary columns which are PO number, arrival time, and departure time as you can see. And the station that I use service will have the waiting time and service time, which are the cell office, inbound wait station, diesel bay, gasohol bay, and the outbound wait. And for the machine fail sheets of diesel and gasohol, it is used to show the maintenance data. As you can see, there is on failure and on repair timestamp and the failure time for both of them.
And this is the data manipulation part. As you see earlier, we have lots of separated tabs for different stages from any logic. So it's very important to clean up the data and stay organized. Here, I basically use VLOOKUP formula with PO number as the search key to match all the numbers into one tab. And for some values, such as invoice number or customer's ID, I generated randomly to match the real-life situation. And for some cases, when we have to classify the gas type, like we have diesel and gasohol 95 over here. For example, cost of goods sold, I have to perform a if statement to refer to another type of price over here and use nested VLOOKUP function to calculate the cost and the price for each PO number. And also for utilization score, I store it separately in this tab, and I did it repeatedly for each station in 31 days, and this is a mock-up for one of them. I customize a formula here to speed up the process, but still it took me pretty much of time to finish it all. And we have a chart here as well, and basically we have to calculate the area under that divided by the total schedule area, and here is the results.
In part tag name design, the structure of part tag name is separated into 4 parts. The part 1 is pan ID by our group is group 2, that is A002. Part 2 is area ID. We show the ID of each area. Part 3 is the data source ID, and part 4 is tag name ID. We have 5 areas, so the first one is O1, loading information, that is data from OVC UA and any logic. The example of data from OVC UA are the value of the sensor, and the example of the data from any logic is the service time for each station. The second one is S1 loading operation. It's used for self-office service by having filling volume of base station, truck ID, PO number, and type of product. The third one is S2 costing KPI for the financial service. It's about daily sold, daily received, and volume of diesel and gasohol 95. The fourth one is ST service performance. That's using for performance dashboard monitoring on web API. The example of data is daily, weekly, and monthly average waiting time of each station, schedule utilization. Next one is S4 OEE. We have create for doing the report by OEE having data about %A, %P, and %OE by multiplying the previous two numbers together for each base station. And the last one is S5 service monitoring. We create for show data in partition. That data about real-time data by example is flow transmitter, temperature transmitter, level transmitter, fueling volume, as well as the availability status of each bay when it has downtime.
For the asset framework for our group, we have created an element for the entire group 2, which contains 7 elements such as bay loading, entrance gate, exit gate, inbound and outbound weight bridge, sales office, and tank farm. Also, in bay loading and sales office, we contain the same things, such as loading automation, loading service, costing KPI, service performance, OEE, and service monitor. Also, in the bay loading, there are 6 fuel bays for our group, which contain diesel bay 1 to bay 4 and gasohol 95 from bay 1 to bay 2. Also, in the elements of these 5 elements, we have created an attribute for like the raw data for arrival time, departure time, filling volume, and flow transmitter. Same as for the loading service, and also the calculating for the KPI such as cost of goods sold, daily sold, and price. Another is a service performance. It's like a cycle time, wait time, and service time. Same these attributes. Another calculation part for the OEE, such as calculation of percentage of A, percentage of OEE, and percentage of P. And these are our asset framework in our group.
This is Pi Vision part. We design the layout based on real flight references. In a normal fuel station, there are big underground tanks connected to the fuel dispenser. And according to what we found, an average capacity of a big tank is around 50 to 60,000 gallons, which is around 230,000 liters. And for dispenser capacity is around 75,000 liters. So that's how we decide the number of tanks required in this case, which is also related to the way we purchase inventory. So there will be two main underground tanks and one supplementary tank for diesel, and one main tank and one supplementary tank for gasoil 95. And each tank will be connected to two dispensers. And here, when every time we change the timestamp, like this, we can be able to track real-time data for each base availability status, level transmitter, flow rate, and temperature. For the OE report, we use PyDataLink. This is an add-in package from Excel that can help us directly retrieve the data from PySystem to our spreadsheet. So here we calculated %A by dividing the runtime versus the planned runtime. For %PP, we calculated the average division of actual flow rate versus the planned flow rate, which is 200 liters per min. And we suppose %Q is 100%, and then we multiply all three together, we will have %OEE. And here we also have graphs to compare different categories among different bases, and the data can also be adjusted by each day.
In part of our website, we create this site for two main purposes. The first one are for system monitoring, and the second one are for the system financial report. At start, we need to log in to access our website. So user need to register usernames and passwords in our database. After login, in this page, we can see the operation data that summarized in every week. For example, this graph shows the data of inventory stock. This one shows the schedule utilizations. This histogram represents the waiting times and the number of fill times at each station. If you want to see the data of the other week, for example, week 2, we need to choose the drop-down list here. This is the data of week 2. We also have a summarize of the data of the month here. This is a graph of inventory of our system. It will show the inventory of the oil in period of month. The next is the operation dashboard. This page is view showing the operation data. In this page, we show the data in period of day only. As you can see, we have a chart of amount of fill, the total sales. So we have a histogram that shows the average of waiting times and the numbers of truck in and out. Same as management page. If you want to see the data of a day, we can select here. For example, we're gonna select we're gonna go to 25 of March and click enter. So in the financial data table, it will show all of the data, like all of the data that happen in our systems. So in this, we apply the intelligent search bar. In this search bar, we can search everything in this table. For example, if we want to see the transactions of this car plate number, we can search by this. And the system will return the transactions of this car plate number only. And if we want to see the purchase number, we can search here too, like this. And the system will show you a purchase number. Next is the monthly income statement. In this page, it will show the income statement of our company. Next is the generalized transactions. In this page, we will show the generalizing transactions of our company. In part of general ledgers, we separate it to be 4 sub-parts. This is a generators of inventory. This is a generator of cash. This is the generator of receivable. And this is a generator of account payable. Let's move to the inventory stock. This page will show all of the inventory transactions that happen in our system. Same as other, we have the intelligent search. If you want to see the transaction of diesel, you can search like this. And it will show you only the transaction that happen with the diesels. This is the summarize of our system. Start with the beginning inventories, purchase, sold, and the ending inventory. And if you want to query it from date to date, you can go to the inventory by date. At this page, you can arrange the times that you want to query. If you want to see it from 10 to 15, you can search like this. And it will return you only at 10 until 15. Yeah. Next is the purchase order page. In this page, we show all of the purchase order that happen in our system. In this page also have the same function as inventory page, which is the intelligent search page that allow you can search the purchase order number like this. And the last one is invoice page. In this page, we show the invoice of our transactions. And we have this search bar. So if you want to see only the invoice of this invoice number, you can search like this. After we use, we can click on log out and it will back to the login page.